Hi students, today we are going to be looking at 4.4, which is matching equations and graphs. So obviously we're going to be looking at these equations right here and the graphs below, and we're going to see if we can match up which way the lines go for each of these particular equations. So the graphs are not in order, and in order for us to figure out which graph y equals 3x plus 3 applies to, we can do it a bunch of different ways, but the way that they want us to do it in grade 9 is they want us to, or they want you to, oops, sorry, erase that. They want you to, full trouble moving my mouse here. There we go. They want you to do some substitution, and by substituting some values in, you can see where they fit on the graph. And if you can see where they fit on the graph, you can identify which line they belong to. So for instance, for the first equation here, 3x plus 3, so y equals 3x plus 3, if we substitute in 0, okay, y equals 3, and then the x is 0, so 3 times 0 is 0, then we get 3, so y equals 3. Therefore, we know that one point is at 0 and 3. So the x is 0, the y is 3. If we look at our graph, we go 0 and then up to 3, so it's right there. Then if we substitute x equals 1, we get 3 times 1 is 3, plus 3 is 6, so we know that it's 1, and then 6. And then we do the same thing with 2, and we get 2, 9. So we see from this graph here, all three of those points are on this line, and if you look up further, that is the same as graph C. So we would say that this one is graph C. And you could do the same with the other questions. I might do them on this piece of paper here. So let's do this one here. We'll just call this one 1, and we'll call this one 2, and this one 3. So let's look at number 2. So for number 2, it's x plus y equals 3. Y equals 3. I like to rearrange this equation so that it's a y equals. That's sort of a thing that you should do in mathematics when you're dealing with lines and linear relations. It's a lot easier if you write it as y equals. So in order to get the y alone, I've got to subtract x from both sides. So what I get over here is 3 minus x. So if I put in a couple of values, let's say y is a 1, or sorry, not y, x is 1. We're always substituting in the x's here. So for x equals 1, then we've got y equals 3 minus 1 equals 2. So that means that we have one point that is x1 and y2. Okay, then we can do another point. Let's do x equals 2. Okay, so that leaves us with y equals 3 minus 2, so y is 1. So that leaves us another point, x is 2, y is 1. Now let's just put those on one of these charts and let's see what happens, okay? We know it's not going to be graph C because we already used graph C. So let's check on graph A. Point 1, 2. So here's 1 and here's 2. And it looks like it is on that point. Let's check 2 and 1. Okay, so we go over 2 and then up to the 1. So it's also on that line. So we can say with a fair degree of confidence, even without checking another number, that this is graph A. Now, obviously, that means that 3 is going to be graph B, or sorry, 3 is going to be graph, whoops, which one didn't we use? Yeah, we didn't use B. So we can say with certainty that this one's going to be graph B, but let's just plug in a few numbers just to make sure. Okay, so for number 3, we've got y equals 3x minus 3. So y equals 3x minus 3. Let's sub in x equals 1. So we've got y equals 3 times 1 minus 3. Sorry, not plus 3. 3 times 1 minus 3. So the y on this one is going to equal 3 minus 3 is 0. So one of our points is x1, y0. Okay, and let's do another one. Let's do x equals 2. So then we're going to have y equals 3 times 2 minus 3. So y equals 6 minus 3 is 3. So we know another point is 2, 3. So let's just check and make sure that those 2 points are on graph B. So the first point was 1, 0. So if we go to 1, and then that's 0 on the y, right? And then let's go to 2. So we go to 2, and then up to 3, and that is also on the line. So we've convinced ourselves, or at least we should be relatively certain, that number 3 is graph B. So the next question, sorry, next page here, what line do these points correspond with? So the equation must graph, I think we we said B on this one. Okay. And for these ones, just, see the previous page. We did it on the previous page. Okay. So let's continue on with some of these examples here. Match each graph on the grid with its equation below. So we've got 3 different colored graphs here. We've got a green, a red, and a blue, and then we've got 3 equations. So let's just number these equations 1, 2, 3. And I think the easiest way to do this is just to do a quick table of values for each. So let's just do, okay, so there's the x, and we got lots of numbers here, so I'm just going to do x is 1, 2, and 0, 1, and 2, and then for the first one, y equals x. So it's going to be 0, 0, and then 0, 1, and then 0, 2. So that's a pretty simple equation. Let's look where those fall. So 0, 0 is right in the middle. Well, that could be any of the 3 because all of the lines pass through that. How about 1, 1? If we go 1, 1, we're there. And if we go 2, 2, we are on graph C. So this one is graph C. Okay, let's look at the second equation. Okay, there's the x, and y equals 2x on this one. So we'll still use 0, 1, and 2 for our x values. You could pick anything, but I picked 0, 1, 2. They're nice, easy numbers to work with. So if y equals 2 times x, this is going to be 0. 1 is going to be 2, and x is 2, so y is going to be 2 times 2 is 4. So we got 0. We already had that one. Now we have to go 1, and then up to 2, which is there. And then we have to go 2, and then up to 4, which is there. So we know that this one is graph A, which only leaves us with 1, but let's just do a table of values anyway. So this is x, and in this one, y equals negative 3x. Let's use the same 0, 1, 2. So negative 3 times 0 is going to be 0. Negative 3 times 1 is going to be negative 3. And negative 3 times 2 is going to be negative 6. So hopefully this matches up with the one graph we didn't use, which was B. So 0, 0, obviously right at the origin there. That one's already been mapped. Now we've got 1 and negative 3. So 1 and then 3 down. Okay, so that's there. And now 2 over and 6 down is there. And it does indeed match up with graph B. So I think drawing a little table of values just with three values in it is plenty for you to decide which line matches up with which table. And if you figure out which line matches with which table, you've got the equations right there. If you can just read 1, 2, and 3 and sub in values in your head and pick it out, that's fine as well. This is sort of the longer way to make absolutely sure that you are matching them properly. All right, example 2. Which graph on this grid has the equation y equals 3x minus 4? Justify your answer. Okay, so the best justification for this would be making a table of values, because then it's obvious within your response here how you got to the whichever line you're going to pick. So I'm just going to go with the same 0, 1, 2 here. So if y equals 3 times x, well, 3 times x is 3 times 0. That's 0 minus 4, so that's going to be minus 4. 3 times 1 is 3 minus 4 is negative 1. And 3 times 2 is 6 minus 4. 6 minus 4 is 2. So let's look at these points. 0 is right there. Negative 4 is right there. So we're hoping it's the blue line. If the other 2 points are on the blue line, then we know for sure. So we go over 1, and then we go to, oh, sorry, where's the origin? 1, and then to negative 1. It's right there. We're still on the graph. Then we go over 2 and up 2, and we are on there. So we know that that matches up with graph 3. And our justification for the answer is really just the table. Is really just the table of values. I mean, that's the way that you can prove to us that you know that all of those points, which are good for that equation, line up on. I'm going to do 4.5 on this video as well, because I thought that, actually I'm not.